Have you ever stopped to think about how massive systems, like a calendar service juggling millions of invites, actually keep track of everything happening all at once? Well, today we're going to pull back the curtain and do a full technical teardown of one single, incredibly powerful function that does exactly that. It's called Get System Events. So, here's the game plan. We're going to start with the why. Why does this thing even exist? Then we'll follow a request from start to finish. After that, we'll pop the hood and look at the core engine, talk about the crucial safety measures, and finally, we'll tie it all together and see why this function is such a big deal. Okay, first up, the admin's God's eye view. Before we dive into any code, let's really get a feel for the problem, the fundamental reason this function was ever built in the first place. Right. Just put yourself in the shoes of a system administrator for a second. You've got thousands, maybe millions of events firing off across countless users. How in the world do you see everything at once? For troubleshooting, for monitoring, for auditing? That's the challenge, right? It's a huge one.
And the answer, at least inside the calendar invite server, is a function built for this exact purpose: Get System Events. Its entire reason for being is to give admins that complete system-wide visibility they need.
Now, the really important thing to notice here isn't just that it gets events, it's that it gets all of them. But look closer at that supercritical detail. It's a restricted function. This is not something that's open to just anybody. This kind of power is firewalled, reserved only for specific roles like system administrators. All right, so we get why it exists. Now let's get into the how. We're going to trace the entire journey of a single request from the moment an admin clicks a button to the data showing up right there on their screen. The whole thing is this really clean four-step dance. It all starts with a trigger, a request that hits the API gateway. Then, the function dives into the DynamoDB database to retrieve all the event records. Next, it takes that raw data and formats it into nice structured JSON. And finally, it returns that data back with a success message. It's simple, but man, is it effective. So we've covered the why and the how. Now it's time to really pop the hood and look at the what, the actual technologies, the code components that make this whole thing tick. So this whole engine is really powered by two absolute workhorses from Amazon Web Services. You've got AWS Lambda, which is the serverless computing brain. It's the code that runs on demand to process the request. And then you have Amazon DynamoDB, which is the super high-performance database where all the event data actually lives. Every Lambda function needs a starting point, and for this one, it's the Lambda handler. The best way to think about this is like the general manager. It doesn't do the really hard work itself. Instead, it gets the request and immediately starts delegating the tasks to a whole team of specialized helper functions. And here is that specialized team. The Get System Event List function is kind of like the coordinator. It calls on Get Event Records to do the real heavy lifting. That's the one that actually queries the database. And as soon as that data is back, it hands it off to format events to package it up perfectly for the response. See how they all work together? Now, this is where it gets really clever. You can't just scan a massive database. It'd be way too slow. So instead, the function uses what's called a global secondary index, or a GSI. It's basically like the index in the back of a book. It lets you find what you need way, way faster. It also smartly filters for only active events and puts a cap on the results so it doesn't overwhelm the system. And this right here is just plain smart design. Instead of burying things like table names or result limits deep in the code, the function uses environmental variables. What does that mean? It means an admin can easily tweak its behavior, like changing how many events get returned or turning up the logging detail without ever having to touch a single line of code. It's a classic example of configuration over code.
Okay, let's be real. A function that can see absolutely everything in a system, that's a superpower. And with great power comes the need for some serious guardrails. So let's look at what keeps this incredibly powerful tool safe and reliable. So how do you lock this thing down? Well, security is obviously job number one. Access is completely locked down to very specific roles using AWS's Identity and Access Management, or IAM, which is basically the bouncer at the door. And just as important, the queries themselves use tenant-based filtering. This makes sure that even an admin can't accidentally see one client's data when they're looking at another's. It keeps everyone's information completely separate and secure. And what happens when things go wrong? Because, they always do. Well, the system is built to be resilient. If some unauthorized user tries to get in, they're stopped right at the front door. If the database has a little hiccup, the error gets logged, but it doesn't bring the whole system crashing down. And for anything else unexpected, it's designed to fail gracefully with a nice, clear error message. All right, we've been deep in the weeds, deep in the technical details. Now it's time to zoom all the way back out for the most important part, the so what. Why does any of this actually matter in the big picture?
I think this quote from the system's own documentation just says it all. The whole point, the ultimate goal, is full visibility. It's all about empowering the administrators, giving them that comprehensive view they absolutely need to manage a complex system effectively.
And that's really the bottom line, isn't it? This isn't just another function. It's a capability. It enables management that is efficient because you can see everything at once, secure, thanks to all those built-in guardrails, and controlled because of its smart, configurable design. So as we wrap this up, I want to leave you with this question to chew on. We've seen how this amazing function gives you total visibility. But with any tool this powerful, there are always trade-offs, right? What do you think is the single biggest risk of having and relying on this kind of God's eye view in any system? Something to think about. Thanks so much for joining me for this teardown.